This is a short video on the second lab about when the Mint changed the composition of the penny. I know you could easily Google this. That wasn't the point. The point was for you to be able to experimentally determine something and then be able to prove that with data. So I know you had to find a bunch of pennies. So you get a bunch of pennies all these years. And what you're going to find here is the average mass of these older pennies is about 3 grams. And then after 1982, everything's about 2.5 grams. So you take that mass, those two mass values, and the pennies are the same size. So what I need now is to determine what the volume is. So you put 60 milliliters of water in a graduated cylinder, and then you put 100 pennies in. The pennies composition, those 100 pennies take up about 36 milliliters. So your ending volume is going to be about 96 milliliters. And so you'll have a volume of 100 pennies is 36 is 36 milliliters, because you started with 96. And then let me start that over. You started with 60 milliliters, you threw some pennies in, and the new volume is 96. So that means the pennies are the reason that it went up to 96. So 96 minus 60 gives you 36. And that's the volume of 100 pennies. Now, the next one, a lot of people made mistakes on about the volume of 1 penny. I was not interested in you throwing 1 penny in. The entire reason I had you throw 100 pennies in is because dropping 1 penny in isn't enough of a change to notice it on the graduated cylinder, or it's difficult to read. So instead, what we did is we put 100 pennies in, and now we just divide that value, that 36 milliliters, by 100. And now we end up with a volume of 0.36 milliliters for the volume of 1 penny. You weren't going to be able to see that on the graduated cylinder. You weren't going to be able to see it go up 1/3 of a milliliter, but you can definitely see 36 milliliter change. So then the density is going to be, I'll throw up so I have like 3 grams, whatever your average for the old penny was, divided by 0.36 milliliters. And that's going to equal, let's see what we got here. 3 divided by 0.36. So I got 8.3 grams divided by milliliters. And then if we do the other one, 2.5 grams divided by 0.36 milliliters, because they're the exact same size. Let's change that to 2.55. And so I get 6.9 grams per milliliter. Okay. So I got these two densities. They're obviously not the same. And so then I asked you to find the densities of these metals down here. And aluminum's about 3. Where's the periodic table? There. So on the periodic table, you can see that aluminum's density is 2.7, and then cobalt's density is 8.9, and copper's density is 8.92. Lead's is 11.34, and zinc is 7.14. So from these densities, what you can do is check these guys out and make a determination. So I'm telling you that the penny is one of these substances. And so zinc is close to 6.9, copper is close to 8.3, and those are those densities. Those are those substances. So the penny was made of copper, and now the penny is made of zinc. It does have a copper coating, but for those of you who put down that from your data, you figured out that the penny was 97.5% zinc and 2.5% copper, you didn't determine that. You looked that up. So that's not what I was asking you for. I was asking you to show me proof that you know what the penny was made of and what the penny is made of. And that's it. That's all. That's it for the video.